All right, ladies and gentlemen, we're going to continue our discussion of PI. That's not the right place, sorry. Try that one more time. PI on starboard. Where's my starboard? There we are. Okay. Careful, this is ASP with no charge. That's ASP that has as many pluses as minuses. On the handout, that is not the ASP that is drawn. On the handout, there are 2 minuses and 1 plus, which means one of those minuses must become a plus. Which minus becomes a plus in ASP? The one with the PKB closer to 4 or the one with the PKB closer to 2? You have the numbers. I did not invent those things, and those things are not on the page. I did 14 minus the 2 pKa's. One was close to 4, one was close to 2. 14 minus 4 is 10. 14 minus 2 is 12. Which is a stronger base, PKB 10 or 12? 10 is 100 times stronger than 12. So the ASP we're talking about in this question is only this ASP and no other ASP. H3N plus CO2 minus CO2H. That's the proton I put on first because that's the PKB. That's 14 minus 10. 14 minus 10 is 4. The F also has no charge, and that is the one pictured on the handout. H3N plus CO2 minus F. And ASP minus means you're going to lose a proton from ASP, which is blue. The proton I just put on is now going to be off, and it will be the one pictured on the handout. And F is going to gain a proton. Clearly, it gained a plus charge. It is going to have the proton on the only place you can put a proton, the CO2 minus. Please give me the pKa of this new proton I put right here. I don't have it in front of me. It's for F. That's an underline. I need the pKa for that underlined proton of F. 2 point, give me 1 decimal, please. 6. And I need a pKa for this. It's directly on the handout, although it says CO2 minus on the handout. 3.86, the guess I have. So it's 3.9. pKeq 3.9 minus 2.6 is close to, is 1.3. KEQ, it looks like they're all integers in the answers above, so make it the best integer, 10 to the negative 1. Nope, don't circle 10 to the positive 1. There you go. Next up, there's a multi-part to this question. You got to ask yourself which H is going to be removed first or added first. So next H goes here. And it goes to pKa equals, please give me the pKa on histidine for that nitrogen. So 6.01, was it? Okay, okay. If this thing's gonna act like an acid, the only H left is this one. And what's the pKa for histidine's ammonium? 9 point something? So 9.2. So if this thing's gonna be an acid, it's gonna go from here to H2NR. And where's it gonna put the proton? It's gonna put it on K2H, so forget about K2. It's gonna become H2ASO4 minus, pKa 7.9. I'm not making this stuff up. How do I know that's the one that's 7.9? Because this is the one that's H3ASO4, and it's, no, oops, had that backwards. The fully protonated one is the H3ASO4. The diprotonated one is the next one. All right. Now, if you're going to park the H here, it's going to go to the nitrogen here. And that's what we're talking about with the 6.1. And what happens to the arsenic? Well, if you're putting a proton there, it took it from the arsenic. ASO4 3 negative, and the pKa for that was 11.5. I almost erased it. pKeq for this bottom reaction equals 11.5 minus 6.1. I know it seems like a lot of work, and it is. That's 4.6. And for the top one, the pKeq is 9.2 minus 7.9. And that's 1.3. Which is the only of those two reactions that's occurring to any extent compared to the other reaction. If they're different by more than 3, which they are, 1.3 versus 4.6, that's a difference of over 1,000. This is a log scale. 10 to the power of 3 is 1,000. The red reaction happens 1,000 times more frequently than the purple one. That's what that means. I only want to look at the red reaction because the wording here, you must choose the answer that would produce the highest amount of products. The red one produces 1,000 times more products than the purple one. That's all. That's what all this work was for. So I want the answer to be the one where pKeq is closest to 1.3, which is the 2. And I want to pick the products that represent the red reaction, H2ASO4 minus, check, no, we're done. We're done. Yeah. They just produced the wrong arsenic. That was the bottom reaction, which doesn't happen. Okay. Yeah, and yeah, so A, answer. Those are two questions that involve a lot of work, but it's 6 points when you think of it. If you've done the first part, the second part's gravy, right? So, I don't know. Good doing our PIs. Quick review. Histidine, I need to keep one of the N pluses, and I need to stay the way it is on the handout, which means the nitrogen on the handout, the 6.1, needs to stay deprotonated, and the 9.2 needs to stay protonated. That way, only one of the nitrogens is positive, and the carboxylate. Oh wait, what am I talking about? What's histidine? I'm starting to look back at the previous problem. I just had a nightmare. Sorry. Histidine is just this piece here, over here, and it has a carboxylate with a pKa close to 2 when it has an H on it, and it has the 6.1 and the 9.2. Do I have all those numbers right? Carboxylate is to balance one of the one nitrogen, and this is to make sure you only have one nitrogen protonated. The 6.1 will not protonate if you're above it, and you will be above it when you do 15.3 over 2. Let's do 15.4 over 2, then you take care of the rounding ahead of time, and that's 7.7. And we got to do them all. ASP, you need to keep one of the CO2s as a minus and put a proton on the other one. We already know which one. The pKb4 reacts before, the pKb14 minus, sorry, 14 minus 4 is 10. Reacted before the 14 minus 2, which is 12. Okay? So the two numbers you need here are, I'm hoping I did it right, 3.86 and 2.1, you said? I can't remember. We're talking ASP. What's the other? 2.1? And that 3.86 should be 3.9. 1 decimal is sufficient for the whole test, everybody. All right? 6 over 2 is 3. ALA, one of your easier amino acids. There's only 2 numbers. You use the 2 numbers. What are the 2 numbers for ALA? Whoa, nice math. 12.3, correct? Is that right? 12.3. In your mind, anytime you know you're going to have to round, just make that 12.4, and you'll be doing the rounding ahead of time. I'm just telling you, if it's an odd number, just go to the next one up, and it'll make your math easier in your brain. So 12.4 over 2 is 6.7, right? No, 6.35, which is 6. Let me get this right. 12.4 over 2 is 6.2. I don't know what just happened to my. So if you do the math straight up, you get 6.15 and have to round to 6.2. But if you realize every time that last decimal is odd, move it up to the next even and do the math, and you've done the rounding ahead of time and the math's easier. I'm just trying to help. Okay. And HISP ASP, I think it's the one we did the whole problem for previously. Which one has a PI molecule in it? I don't know. To do PI molecules, I always have to think of the fully protonated and then move on from there. Fully protonated, we're talking about HIS, ASP. I always get a kick out of that, HIS, ASP. And the asp is a snake, especially in the Old Testament. And hiss is the sound a snake makes. So there's no accident I chose hiss asp. It's just bizarre. There's the fully protonated form, clearly not the PI molecule. I got to get rid of 2 of the H's to make 2 minuses to balance the 2 pluses, right? You ain't be taking none of the NH's off before you're taking the CO2 H's off. We're supposed to know that from 241. Carboxylic acids are much stronger acids than ammonium ions. You've got the numbers to prove it. You don't even have to memorize it. Clearly, you have to take 2 of those H's off. So this one's off first, off second, and keep off. So there's one of your numbers. What is the number? Was it 3.9? ASP, the bottom CO2H. Good. Now, which of the NH pluses comes off first? The 6.1 or what was it, 9.3? I can't remember. 9.4 with rounding? 9.2 with rounding. It doesn't matter which one comes off first. The 9.2 is irrelevant, right? Keep off, keep on. There's your only 2 numbers that mean anything. I got to keep that one off. Or take it off and keep it off is what I'm saying. This one, keep it on. So do not go above 6.1. Do not use any other number except for 3.9. And this is 10, right? Over 2, which is 5. And the question is, increasing PI. Lowest was the 3. If you're like me, I have to do this. If I don't do this, I got a random error in there. I should have 4 numbers, right? Oh, this was the 3 right here. So lowest is 3, 2 is 3. Next is the 5.0, which is IV. correct? 3, 5, 6.2, 7.7. Okay. And then 3, and then 7.7 is 1. There's your final answer. 2, my final answer, 2431. 2413, gosh darn. So you're gonna find it before me for sure. I hate when it's not there though. Oh, there you are. 2431, AB. Good activity. I don't think question 5 made it to this one. Moving on, we got work to do. We got a question first though. Divided by 1 instead of 2. So that is the Roman numeral 1. Oh, divided by 2. Thank you. Yeah. Since I'm tidying up, here we are. Thank you. And now we can stop.